that make something specifically a rectangle instead of a parallelogram is the 4 right angles. And for a parallelogram, diagonals bisect each other. That's our parallelogram rule. But to take it a step further for a rectangle, the diagonals are bisected, but they also are congruent. So that's that little added part. All right, so we're just going to jump straight into solving. So find within the length of the quadrilateral. On that quadrilateral, is there enough markings to know what type of quadrilateral it is? Yeah. What's the marking that tells you that you have a special quadrilateral? The right angles proves that it's a rectangle, right? So just because of the markings, it guarantees that it's a rectangle, which means our opposite sides are congruent, which means we can set up our two equations, which means we've got a system on our hands, which means you can solve it. I'll let y'all do it. Yeah, so 12 and 24. Oh man, I thought I had it. 12 and 24. Okay. So solving a system or solving a quadratic, that's our complicated version of those kinds of problems, but it's just more algebra into our geometry stuff. On this next one, how long are MO and MD? Okay, what's true about your diagonals? They're congruent. Yeah, it says NL is 26, which is one of the diagonals, which means MO is 26. And then that's our rectangle property. Diagonals are congruent. But then if we need MD, what's that going to be? 13. That's from parallelograms because that also applies to a rectangle. Bisected diagonals. Okay. The next two that we're going to look at is if we have a coordinate, like coordinates. So proving that we have a rectangle based off of coordinates. I'm giving us specific things that we have to use. If you're not given specific ones, you can use whatever methods you want to. This one says we have to use the slope formula. So -1, 0, 2, 3, 4, 5, 2. Since this one is saying to use the slope formula, what are we trying to prove when using that formula? That the sides are perpendicular. Okay, that is something that makes it specific for this rectangle because it says perpendicular. The consecutive, like the sides touching, that create the different version to make those 90 degrees. So we need to compare the slope of DC to the slope of CB to the slope of AB to the slope of AD. DC, that's going up 2 and over 6, right? 1/3. Slope of BC. -3. AB. Okay, 1/3. And AD is -3. So we proved those are perpendicular. We proved those are perpendicular. We also have that these are perpendicular and these are perpendicular. So all of our sides are perpendicular, meaning we have 4 right angles. Ta-da! Yay. Are you ready? Yes. The next one is using the distance formula. How could you use the distance formula to prove you have a rectangle? diagonals have to be congruent. So that's our process that we're going to go through. So -2, 3. And I want y'all to do this one. I'll give y'all, I'll actually give you that. Jumping. So we're trying to prove diagonals are congruent, so JL is equal to NK. So we just proved that diagonals are congruent. Does that alone prove we have a rectangle? Look on that purple paper that lists all the different properties. Where else are diagonals congruent? What other figure has that property? A square. Okay, what else? An isosceles trapezoid. So, just because we proved that diagonals are congruent, we didn't just figure out we have a rectangle. We could have technically, now I see us looking at the picture, it definitely looks like a rectangle, but we haven't fully proven it is without a doubt a rectangle. There's still a possibility, technically, of being like an isosceles trapezoid. So I'm not going to make us do it now because it's just going to be, you don't have to. But what we would also need to prove, if all we were using was distance formula, we would also need to prove that JK is equal to ML and JN is equal to KL. Because we would also need to just, that would further clarify that it's also a parallelogram, which would take away the isosceles trapezoid option. And it would also show that all the sides aren't congruent either. So that way it's not a square either. I'm not going to make us do it, but if it were a test or a quiz, you would have to. Most tests and quizzes, I probably won't be telling you exactly what formula or what you have to use to prove something, most times. So sometimes using distance formula only makes a lot of work, depending on what the shapes are. So just being careful with that. I'm not going to make us do it, but you would have to if it was a test or a quiz.
Could you just do the perpendicular?
Yes, you could. That slope formula one? Mm-hmm. If it was like, if the rectangle was made of like just horizontal and vertical lines, then that's not that big of a deal, you're just counting. But if it's having to actually use a distance formula, just makes it a lot longer. Okay, the last page, there are 3 sets of problems. I'm gonna have y'all work on those 3 sets of problems and do them without me, but there are 2 that get crossed out. The bottom, number 2 and number 3, you can't solve them without using trigonometry, which we have not learned yet. So we're just crossing it out. So you don't have to solve those. But I do want you to solve the rest of those problems and then let me know when you're done. And I'll come check it. If you're right, you can move on to the homework stuff. Because this is our last set of problems for today. So when these 2 have to be congruent, so that means this is 34, which is where that 68 is coming from, right? Because the measurement angle 1 is technically the exterior angle of this triangle down here. So you just add those 2 numbers together. Or you can figure out that that piercing one is 12 and then there's something like that. Okay. The rest is pretty self-explanatory, I think, for the most part. I just want to make sure you all saw that.